Great day, learners. This is a full paper solving of 0607 Cambridge International Mathematics paper 6 and its combination 6-1. We are going to solve investigation and modeling. Let's start the paper. So we are going to start with part A, investigation. The topic is largest products. Let's start reading the question. This investigation looks at finding the large product when two or more positive integers have given a sum. For the positive integers 2 and 5, the sum is 7, the product is 10. Complete the table for all the different pairs of positive integers that have sum of 8. So for 8, what are the different possibilities we'll be having that we have to write it here. Sum has been given already and they have mentioned it as 8. We just have to write what will be the product value. So if first integer is 1, then another integer should be 7. Then only we will get the sum as 8. If the first integer is 2, the second integer is 6, then third one they itself have filled it, and fourth one is first integer is 4, so the second integer is also 4. They itself have filled the product for 4 fourths at 16, and here let's see what are the values we are getting. So the next thing what they are asking is write down the calculation that gives the largest product. So which calculation is giving the largest product? It is 4 into 4, that is equals to 16. Why we are getting only in that 4 into 4? Actually, as a teacher, I'm giving you this advice. If you are going to find out that largest product and the sum has been given, then how you have to find it? Just divide that number by 2. Since for this problem that given number is 8, if you divide by 2 it's a 4, so both the numbers are going to be 4 into 4, so maximum product is going to be 16. So when all the numbers are going to give the same sum, and where we will get that the maximum product, that is going to be the mid value. That's why I have divided by 2. You might ask me that suppose if it is an odd number, then what we have to do? For the odd number also, you just divide that number and the two next consecutive integers will be taken. For example, if you are taking 15, then 15 when you are going to divide by 7 in the sense the previous integer and the next integer, just 7 and 8, if you take that only will give that 56 as answer. If you have doubt, you can check that. Suppose if you're taking 6 and 9, will give the sum as 15, but 6 into 9 is going to be 54. But as I said, if you are going to take 7 into 8, it's going to give the product as 56, and that is the maximum. And if you want, you know that it's clearly 7 plus 8 is going to be 15. So this is the concept you can use, and it's basic. Not only here, even you can use it for the other concepts, other papers, paper 2 and paper 4, even for other combinations you can use. Let's go to the next question. Find the largest product of two positive integers that and I have a sum of 20. So just now I have told you just have to divide by 2. If you divide this 20 divided by 2, you'll be getting that number as 10. So what will be the product? We'll be getting 10 in the sense 10 into 10, it's 100. Write down the calculation that gives this product. It is 10 into 10. But if you are not trusting me, you can check what are the values you'll be getting here. 119, 218. So all the sum and all the pairs you can take and you can check it out. Since I know it, you can take this as a knowledge and then you can proceed. So here is our question B. Complete this table for all the different pairs of positive integers that have a sum of 9. Note that 2 and 7 is the same pair as 7 and 2. So they are saying that you don't need to repeat the values. So only that the unique digits if you are using, that's fine. Since the sum is 9, then 1 and 8 are the possibles, 2 and 7, 3 and 6, 4 and 5. As I said, the two consecutive integers are only going to give the maximum product. If you're not trusting, you can check here and you may trust after this. So here we are getting the product as 3, 6 are 18, and this is 14, actually 2 7s are 4, 5 are 20. So you can check here. Here we are getting that largest product. Write on the calculation that gives the largest product. It is 20. Find the largest product for two positive integers that give a sum of 21. So I told you already. So what you have to do, 21, if you are going to divide by 2, it is nothing but 10.5. 10.5 in the sense, you know that what are the two numbers you have to take. It's 10 into 11. So the product value is going to be 110. Write down the two positive integers that gives this product. It is 10 into 11. Keep that in your mind. It should be that consecutive. Then only you will get the maximum. Okay, here we are entering into that subdivision 2. Tom wants to find the set of positive integers that have a sum of 19 and gives the largest product. He uses the ideas from question 1 and then the following method. Write 19 in the top box of the diagram. Yes, it has been written. Write the two positive integers that gives the largest product in the two boxes and the next row. We know that 19 in the sense 19 divided by 2 is 9.5. So one will be 9 and another one will be 10. So that we have to write it here. Complete the remaining boxes in the same way. How did they do? So for example, if it's 10 now, if you are dividing by 2, it's going to be 5, and even here 5. 5 they have divided by 2, 3, 2, 3, and here 9 in the sense it's nothing but 4 and 5. Yeah, they already did. So only these numbers we have to fix. We cannot write like 5 and 4. Okay, then the largest product using Tom's method is, okay, so what he has done is previously we have taken only that 9 and 10 and we got the product, but they are doing it to the maximum level. So like 9 in the sense 4, 5, 5, 5, then again they are that dividing that into 2, 3. So every number if you are taking, then that's will go to the maximum of 2 or 3. So that's what they have done here. The largest product using Tom's method is, okay, so 1, 2, 3, 4, 5, 5, 2. So 2 power 5, 1, 2, 3, 3 power 3, that gives 864. You can check in your calculator and it would be correct. Explain why Tom does not replace the 2's and then 3's to make another row in the diagram. Why he did not do that, the 2's and 3's? So actually you can see that here he has 4, 5, 5, 5, but that he has replaced by 2 into 2, 2 into 3, 2 into 3. Then they're asking why he did not replace the 2's after that, why he did not proceed the next row. That is the question. So suppose if he is going to proceed, then what he will be getting? It's going to be like 1 and 1, and even this is also going to be 1 and 1, the sum, because we are dividing it as a sum. Even here this is 1 and 1 and this is going to be 1 and 2. But you know that, so you just check 1, 1, 1, 2, 1, 1, 1, 2. So it will be 1 and 2. It will give the least product. Actually it's not going to be the maximum 1. If you see, because 1 and 2, 1, 1, 1, 1, 1. So only 2, 2 are there. Then again if you are going to proceed, then it will give only 1. So if he proceed, if he proceeds to the next row, next rows, all the numbers will become 1 and the product is also become 1 and it is not largest. And it is not going to be the largest. So you can write in your own words, whatever the words you want, so you can use and write it. I hope you have got what is the point. Why he did not produce, why he did not proceed to that next row, because 2's and 3's, if he is going to proceed, then everything will become 1 and 2. Then the product, that everything, that final product is going to become 1. You can ask me how, because here we are having 2, 2, 2. How it will become 1? Because even if you are proceeding to the next row, this 2 will become 1 and 1, 1 and 1. So actually it will not make sense, because we are going to find out the largest product. So we have to stop in 2 or 3, because that is a consecutive integer we will be getting it. If you are taking 1 and 2 as the consecutive integers that will give the product as only 2, it's not going to be the maximum, so that you have to stop at the value of 2. Okay, I hope this is clear. Let's go to the next one. Complete the diagram and find the largest product that Tom's method gives for positive integers that have sum of 22. 22, we know that it's going to be 11 and 11. So let's fill one side so that the same will be getting in the next side. So 11 is an number, so we'll be getting 5 and 6 here. 5 is nothing but 2 and 3. Then 6 will be 3 and 3. Here also same, 5 and 6 will be getting here. 5 is going to be 2 and 3, and 6 is going to become 3 and 3. So if you want, you can box it and write it. And we are going to write that finally what is the sum is, because we have to find the what is the largest product is. So we can check here 1 2 2 2 we have here, so it's going to be 2 power 2 into 3 power 1 2 3 5 6 3 power 6. It's giving the answer as 2916. That's it, we found it. Let's go to the next one. If any set of positive integers, the replacement of a set of 3 2's with a set of 2 3's. So read again, in any set of positive integers, the replacement of a set of 3 2's. Set of 3 2's means, however we are going to write the numbers like 2 plus 2 plus 2 or 3 plus 3 plus 3, like that only we are going to write it. So they are saying that 3 2's. What is a 3 2 is? It's going to be like 2 plus 2 plus 2. This can be replaced by set of 2 3's, like 3 plus 3, and it will not change the sum. Why? Explain why this is correct. Because if you add the set of 3, we can write set of 2 3's, or sorry, here set of 3 2's. Sum of, we can write sum of set of 3 2's equal to 2 plus 2 plus 2 equals to 6, and sum of set of 2 3's going to be 3 plus 3 6. So both are giving the same sum. So to get the same sum, so we can use this. You can say that therefore the sum is same. Okay, next, explain why this replacement will always increase the product of set of positive integers. So here they have asked why this one set of 3 2's can be replaced by 2 3's, and they are asking why this replacement will increase the product. Let's check here. Suppose if you are having 2 into 2 into 2, it's going to give that answer as 8, whereas 3 into 3, because 2 set of 3 is going to be 9, so the product is higher. In 3 by 3 or set of 2 3's. Okay, so that's why we are replacing it. Then next, here is Tom's results from question 2a. Yeah, so for the question 2a, you can check here. So here it is there. He has written that 864, the largest product, and then we have to use this replacement, and let us check whether we will be getting that any other answer or not. We don't need to go much, and then let's take here 2 power 5. 2 power 5 is nothing but 2 power 3 into 2 power 2. So this 2 power 3 can be written as 3 power 2. So into 2 power 2 remains the same, and this 3 power 3 we can bring it here, so that how that values will get changed. It's going to be 3 power 2 and 3. This 2 we can combine, and we can write as 3 power 5 into 2 power 2 is the value. And let's check what is the product is. It's giving us 972. And if you are proceeding, or write your answer to part 1 as a product of powers 2 and 3. Let's start with 2 because that's the smallest number. So 2 power 2 into 3 power 5 is the answer we'll be getting it here. And you can check here, yes. So though when we are using the 2 and 3, we have got the largest product, but when you are replacing the 3 twos by 2 threes, actually it has increased the product more. Yeah. The next one is the sum of a set of positive integer is n. So we can check here how, what are they? So first let us come here. What is 2 power 5, 3 power 3? It is actually how many 2's we have added. If you are going to this question, then it will be giving you a clear idea. So if you add all these numbers 2, 2, 2, 2, 3, 2, 3, 2, 3, it will be giving the total as 19. So you can see here 2 1 2 3 4 5 5 2 are there. That's why we have written 2 power 5 now. There are 5 2. It is 2 power 2 into 5, and 3 3 are there. It's 3 into 3. So totally we are getting 9. So what is that power value? When to check that product, we have to take it as a power, but to check what is the sum, we have to multiply the power value with the base. And even here 3 power 3, now it's going to give 9. So that's what we are going to do. That's the thing that they are expecting here. 2 power x and 3 power y. Now what is it? What is 2 power x is? If I have to get the sum, so sum is nothing but 2 power x. If I want sum, I have to multiply how many 2's I have, that all I have to add it, that is 2x, and 3y I will be getting. Next, they have mentioned it here. It's going to give the largest product, and explain why x can only be 0 1 or 2. So why only it can be 0 1 or 2? Why it can't be more than that? Because just now we have seen that we have a replacement, because we have replacement for 2 power 3, that is 3 power 2. So 2 can be 2 power 1 or 2 power 2 or 2 power 0. Sorry for the wrong order. Only these are the possibility. If it is, you can ask me 2 power 4. 2 power 4, now we'll be taking the 2 power 3 and we'll be writing that as 2 power 1. So because this example is the one great example for that, we can check here. Yeah, 2 power 5 was there, but the 2 power 5 we made into 2 power 2, because 2 power 3 we have taken the multiples of 2 power 3, we are taking it out, so that it won't be more than that. The next, use part A to find the largest product for a set of positive integers that have a sum of, okay, they gave the sum, then how we are going to find out uh, the what is the largest product is. So what is that? A 2, it can be either a 0 1 or 2 only possible. So let uh, divide the 60. First we will extract that 2 out. Before that, let us check whether it is a multiple of 3 or anything else is remaining, then we can do it. But we know that clearly that 60 is a multiple of 3. 23 times 3 is giving that answer as 60. So 3 power 20 is going to be the answer into 2 power 0, because there is no 2 in it, everything has been taken by 3 itself. And if you put this value in calculator, why we have to put this? Because we have to find out the largest product. If you are doing it, then we'll be getting the answer 34867844401. The next is 62. Just now we have seen for 60, 60 in the sense it's 3 power 20 is there, and one more 2 is extra here, so it's nothing but 2 power 1, 23, and 2 power 1. And if you put this in your calculator, you'll be getting that answer as 69735688802. Next, 6377292 is the largest product of a set of positive integers that have a sum of n. So they gave the product here. Previously they have given the sum, and then they have asked us what is the largest product, but here they gave that the largest product is what. And yeah, so let us check first initially how many 3 are there. That's what we have done for previously. So if you are going to check that, because uh, we will check that what is the value we'll be getting for in terms of 2. You can check that what is a 3, it can be, you can check by, since we have to find out what is 3 power y is, if we have to find out the power, then we know that we have to use this log value. So log 6377292 divided by log 3 you can do for y. You won't be get that the proper answer, because not only y is, I mean 3 is there here, it is 2 is also inclusive. So what are we going to do here? So for this, first you extract the 2 here. 2 can be extracted, so 2 power 2 is extracted, and just divide this whole value by uh, 2 first. So 2 times you can take the 2 out, so that it is going to remind that only that multiples of 3, 2 power 2 into 3 power 13. So this is what the answer, and x value is 2. Suppose how you have to add the number, if you have to find out that n equal to 2 into 2 plus 3 into 13, we will be getting the answer as 43. You can ask me how did I get this answer, because you just the given number you divide by 2 first, so what maximum. So first of we are going to do it, 6377292 divided by 2 will be getting one number. Again, if you are doing it, then after that we are getting one odd number, like a 2 power 2. After the extraction of 2 power 2, then we are getting one odd number, that is 1594328. This is what we are getting, and this is full of 3. We know that because either it can be 2 or 3, so this is full of 3. How to get to how many 3 are there? It's very simple. As I said before, y equals to log of right hand side value, because 3 power y is equal to 1594328 we are getting. So to get y, what we have to do, log of that right side value divided by log of 3, that will be giving you that exact answer, that 3 power 13. So that's it, we have finished. Let us check how we have to solve modeling. So we are going to solve that part B modeling. It is counting prime numbers is the topic. Prime numbers have only two factors, 1 and the number itself. In this task you will see models for the number of primes in a given range. The function p of x gives the number of primes that are less than x. So if you are taking any number and before that lesser than that, how many number of primes are going to be there, that has been denoted by p of x here. For example, p of 10 means it's 4, which means until 10 how many prime numbers are there, how many numbers are there, number of primes, it says that. So 10 and until that 2 3 5 and 7 are the prime numbers, so totally they are 4, so that's why they have written it as 4. Show that p of 20 equals to 8. So already they have given that for p of 10. So after 10, if you calculate what are the primes are there, then it is going to be good. After 10, it is 11 is a prime, 13 is a prime, 17 is a prime, and 19 is a prime. So already we have 4, and here we have 4 more. So p of 10 plus here some more numbers, 4 plus 4. It's going to give 8 as answer. So p of 20 we are getting as 8. So next p of 40 is given as 12, then find p of 50. So only thing what we have to do is that prime numbers between 40 and 50. So we know that the prime numbers are 41, 43 and 47 are the only 3 prime numbers. So already we have 12, and then here 3 more we are having, so that it's going to be 15. Next, they gave p of 100 is 25, find p of 90. So they gave that outer var range, and then they are asking what is it inside ranges. So until 100 it is 25, so we can find between that 90 and 100 what we have, then we can subtract that from here. So we know that in between 90 to 100 that only one prime number is there, that is 97, because 91, 93 they are all multiples of 91. Is everything is not a prime number, only the 97 is a prime, so only one number we have, so that p of 90 is going to be 24, because here we have 25 and one number only is there between 90 to 100, so it's going to be 24. Next, so for 10 we have filled, for 20, for 40, for 50, actually what is the answer we got, it's 15, and for 90 it is 24, 100. So the remaining all the numbers are there. On the grid, plot this information. The first 3 points have been plotted for you, and I know that you're all very good at plotting. Just plot the points like 40, 12. So 40, 12, it has been plotted. 60 in the sense 60, uh, 90, 24 alone. If you plot it's fine. So 90 and 24. Just plot it and leave it because they did not ask you to join as curve. And when we are going to the next one, a model L of x for the number of primes less than x is a straight line that passes through the points 40, 12 and 140, 34. Find the equation of the line, and they said that it is actually a straight line, which means it should have the gradient, and we know how we have to get the gradient. That is y2 minus y1 by x2 minus x1. If you use that formula, we'll be getting that answer as 22 divided by 100. If you have doubt, you can check, and that simplified answer is going to be 11 divided by 50. So equation we can write in the form, once we found that m, so we can write that y equals mx plus c. M is here 11 by 50x plus c. To get the value of c, we can substitute any one of the point. So let's go ahead with this point. If y value is 12, so 11 by 50 into 40 plus c. If you simplify this, we will be getting that answer c as 16 divided by 5. It's simple calculation. Just find this value and then move to this left side, so it will become 12 minus answer. So there you will be getting that answer of c as 16 by 5. And they have actually equation of line is what they are asking, so that it's going to be y equals 11 by 50x plus 16 by 5. Next, use your model to estimate the number of primes that are less than 1000. So by using this model, because they have told that L of x is the number of prime less than, this is the model actually we are using it. If you are using it, they gave that y value, actually y value is what, how many numbers that we have to calculate. Less than 1000 we have to find it. So x value has been given, y equals 11 by 50 of 1000 plus 16.5, we have to add 16 by 5, sorry. If you simplify this, we are getting 223.2, which means this 0.2 cannot be considered, since we are going to find out the number of primes. This 0.2 means actually it not making sense, that, and we know that it is 223 because it's a number of primes and it's just a model. It will not give that always the perfect value. Next, a quadratic model q of x for the number of primes that are less than x is, okay, so they gave another model. It's a quadratic model. Previously they gave linear model, straight line. Now they gave quadratic, kx minus 0.001 x square. The model estimates that there are 34 primes that are less than 140. So 34 primes are there. That q of x has been given as 34. That is equal to 140x minus 0.001 140 square. Oh my god. Find the value of k. Yeah, we have substituted, and actually this is not going to be x, it's actually k, because kx is the value. X is 140, so that kx is going to be 140k, and this number can go that side and 140 can divide. So if you do, we will be getting that answer as k equals 0.4. So what you have to do is, first this part should go that side so that it will add, because it's subtracting here. Then after that, this multiplication 140 will go that side and divide. We are getting that answer for k is 0.4. So we can replace and write that answer what we are getting. The model is quite accurate for the number of primes when x less than 200. Why is the model unsuitable for the number of primes when x greater than 200? Why this model is unsuitable, they are asking. So what you can do is, you can draw the curve. Which curve has been given? It is q of x is equals to 0.4x minus 0.001 x square. So this is the curve you can draw and check. You can see that after the 200 it will start reducing, or else you can check in the calculation. Suppose if you are substituting x value as more than 200, you'll be getting that the prime will be getting reduced. So that's what the reason we are going to write it. After 200, number of primes getting decreased. Maybe we can show the calculation after 200, that 0.4x minus 0.001x square is reducing. You can put one of the value and you can check here. Suppose if you're substituting 0.4 into 205 minus 0.001, 205 square. Actually, the prime has reduced to 39.975. Because why it is happening now? Actually, this is a negative. So when this value is getting greater than this, then obviously it will be reducing. So only it is possible until 200. After that, it is not possible. So let's go to the next one. A very good model for the number of primes less than x, where x is less than 1000, is n of x equals to x divided by 2 log x base 10. So log 10 it is pre-installed, so that we no need to use the base as 10, because normally that's what we will be using it. They are saying that it's a very good model. Previously we have seen that one of the L of x linear model and quadratic, it is q of x we have seen. Now they gave another one, it is n of x. Use the model to find how many primes there are that are less than 400. So in this, if you are substituting 400 just to 2 log, it's 400, you just have to put, we are getting the answer is 76.8, and it's closer, it's exceeding that, so that we can see that there are 77 primes are there. Then less than 800, if it's less than 800, in the sense just 800 divided by 2 log 800, we will be writing it. If you put this in your calculator, we are getting that answer as 137.7. So that is nothing but 138. Since it's above 5, I'm adding it. Even if you're writing this is 76 and 137, it's okay, it will be accepted. Use your answers to part A to complete the table. Actually, they gave that in between 0 to 200 there are 44 primes. Then how many primes are there in between 200 to 400? Actually, until 400 there are totally 77, which means 44 have gone before in the previous interval, which means the remaining 33 will be here. Until 600 there are 31, so 44, 33, 31, and total it's going to be 138. So that from the 138, if you subtract these three numbers, we are getting that answer as 30. Yes, that's it, we have filled. Let's go to the next one. The model is still good model for x is greater than 1000. Actually, they have mentioned it here, it's a very good model until less than 1000, but now they are saying that even if it is more than 1000, it is good. Okay, a number is chosen at random from the numbers 1 to 10,000. Use the model to estimate the probability that it is a prime. Let us check how many primes are there in between less than 10,000, because they have allowed us to take that number until 10,000. 1 to 10,000 means it's until 10,000 or less than 10,000. If you are using it, we will be getting that answer as 10,000. In the model, when we are applying it, it's 2 log 10,000. Actually, we are getting that answer as 1250. So since we have to estimate the probability, there are 1250 success out of 10,000 chances, because the success is considered only that prime and numbers are 10,000, so that we are getting that probability as 0.125. Next, a number is chosen at random from numbers in the range 1 to x. So they did not give what is that maximum range is. Find in its simplest form a model for the probability that it is prime. So like what we have done before, that we have to generalize it here. Probability na, we know that that total value will come in the denominator here, 1 to x, which means until x, so x will come to the denominator. Numerator is the model is what we are using. What is the model? It is uh, if you want to just have a look at it, this is the model, x divided by 2 log x. So x divided by 2 log x base 10, it's not required, that is the probability. And here you can combine both the denominators. Actually we have two denominators here, it's going to be x into 2 log x, and x can get cancelled, so that we are getting the answer as 1 divided by 2 log x is the simplified one. Okay, next use the model n of x equals x divided by 2 log x to estimate the 100th prime. What is meant by 100th prime? Previously we have seen that until this how many prime are there, so they will be giving that a bigger number, and in that how many primes are there, that will be finding by using this model. But now they are asking what is a 100th prime, which means uh, so sum of numbers which is more than 100 is there. In that, what is actually 100th prime? What is that? So they gave 100 primes are there. They are saying that indirectly, if they are asking what is the 100th prime, now in the group there are 100 primes are there, which means n of x value is 100. So 100 equals x divided by 2 log x. Then you will be asking me how I have to solve this. Then why do we have GDC here in our hand? Just put this x by 2 log x as a graph. Just draw the graph for this, and actually they gave the y value, they're asking x value. Just go to x calculate. Then in that, if you give y value as 100, then you will be getting the answer as 547. So 547 is the 100th prime approximately. Yes, that's it. So actually, even for the previous things also, we can use it wherever it is possible. So GDC can be used, and here no other go. That is the thing that we can use it. And yeah, paper is over. We'll meet in the next paper. All the best. Good luck.